Here's the Math 3 review key video. So I'm going to go through every one of these problems in the review sheet, and hopefully this will help you study for your test on Friday. So the first thing, we got the closure property. All right, what we're going to do is we're given two functions. We're going to do the operations set out in the boxes and explain why it's either open or closed. Okay. So the first one, we're doing addition. So we have 3x squared minus 2x plus 4 plus 2x plus 5. Now, we're going to put these in parentheses just for the sake of argument and because we're going to do it in subtraction as well. But all we're doing here is combining the like terms. We're not multiplying. We're just adding up like terms. So 3x squared, there's no other x squared term. Negative 2x plus 2x is going to be nothing. It's going to be going away. And then 4 plus 5 is 9. So we're left with a polynomial, which is why it is closed. Because we started with two polynomials and we ended with a polynomial. It's because it is still a polynomial. Okay. For subtraction, we have 3x squared minus 2x plus 4 minus 2x plus 5. Again, we're just combining the like terms, this time with subtraction. So 3x squared still has nothing to combine with. Negative 2x minus 2x is negative 4x. 4 minus 5 is negative 1. So again, this is still closed. We started with two polynomials. We ended with with one polynomial, but it's still a polynomial. Multiplication. I'm going to actually write it a little bit different this time. So it's 2x plus 5. Parentheses are on both things. And then 3x squared minus 2x plus 4. Doing it this way because I'm going to show you this using the rainbow method. Just multiply each line in its terms, and then combine the like terms. So 2x times 3x squared is 6x to the third. 2x times negative 2x is negative 4x. 2x times 4 is positive 8x. Sorry, this should be x squared. All right, then we do the 5. 5 times 3x squared is 15x squared. 5 times negative 2x is negative 10x. 5 times 4 is positive 20. Combining the like terms, we get 6x to the third plus 11x squared minus 2x plus 20. And it is closed as it is still a polynomial. Started with two polynomials, we ended with a polynomial. Now division, we're going to take the terms of the larger one, so it's going to be 3, negative 2, and positive 4 as the line for our division. We're going to do synthetic division. I'm going to solve the 2x plus 5 for x, which means I'm going to get negative 5 over 2. Okay, so we can still do synthetic division this way. There's some complications at the end. But if you've watched the synthetic division video, it explains what they are. We drop the first number down, which is a 3. Multiply 3 times negative 5 over 2. Gives you negative 7.5. Add that up with negative 2, gives you negative 9.5. Multiply that by negative 5 over 2 again. Gives you 23.75. Add that up to 4, you get 27.75. And when you're doing the synthetic division, you take the remainder and leave it just the way it was. 27.75 over 2x plus 5 as my remainder. And the other terms that are left, you divide them by your denominator of whatever you were using in that little box. So that would be a 2. So 3 divided by 2 is 1.5x. Minus 9.5 divided by 2 is 4.75. So this is open because we started with two polynomials, but we ended with something that's not a polynomial. It is something else, which is why it's open. All right, let's try the next ones. So for these problems, you're just going to do synthetic division to help you find the a or the missing value that's in there in your problem. So we're going to take all the terms of our polynomial, we have 1 in front of the x to the fourth. We have negative 4. We have a. We have negative 8. We have negative 42. Notice the signs follow the numbers down. If I take x minus 7 and solve it, set it equal to 0 and solve it for x, I get positive 7. And now I'm just doing synthetic division. Okay, I want to go as far as we can until we get to a point where we can't go any further, and then we're going to go to the end. So let's show you how this looks. Drop the first number, which is a 1. 1 times 7 is 7. 7 minus 4 is 3. 7 times 3 is 21. 21 plus a is I don't know what number that is. Okay, so that's where we go to the end. Now, because we're told that this is a factor, that means this last number down here in the corner has to be 0, which means negative 42 plus 42 equals 0. All right. How do we get the positive 42? We had to multiply something by 7, which would have been a 6. Okay. To get a 6 with negative 8, we would have had to have a positive 14. To get a positive 14, we would have had to multiply something by 7, which would have been a 2. Okay. Now, this is the column we want. We're going to set that column and make it an equation. A plus 21 is equal to 2. Subtract 21 from both sides. We get a is equal to 19. Negative 19. All right, that's it. Doing the same thing in the next question. We have 1 for x cubed, 9 for x squared, c for x, and 15 for the no x's. X plus 3 set it equal to 0 and solve for x. We get negative 3. Do synthetic division to find our values. Drop the first number, which is a 1, times negative 3 is negative 3, plus 9 is 6, times negative 3 is negative 18. We don't know what the value is from there, but we can go to the end. This has to be 0 because it is a factor, which means this has to be negative 15. To get negative 15, we have to multiply something by negative 3, which would have been positive 5. So we have our equation is found in that column. C minus 18 equals 5. I'm going to add 18 to both sides. So C will equal 5 plus 18, which is 23. That's all you got to do. All right, moving on. So now we're just going to use synthetic division to find another factor. So all we have to do is do synthetic division with this factor that we're given. Again, we're going to bring down all of our numbers. We got 2, 11, negative 17, 26, negative 14. Again, I can't stress this enough. Make sure the signs follow the numbers. If x plus 7 was your factor that you were given, that means if you set it equal to 0 and solve for x, you get negative 7. So here we go. Drop the first number, which is a 2, times negative 7 is negative 14. 11 minus 14 is negative 3, times negative 7 is positive 21. 21 minus 17 is 4. Negative 7 times positive 4 is negative 28. Plus 26 is negative 2, times negative 7 is 14. When you add those, you get 0. So we started with x to the fourth. We divided by an x. Where did it go? Over here. Which means we have 2x cubed minus 3x squared plus 4x minus 2. That is the other factor that we just found using synthetic division. All right. All right. We might not have seen this terminology over here on the right-hand side. All this is saying is you're dividing. So the problem with this question is that we're missing a bunch of pieces. We have 1 for x to the fourth. We have 0x to the thirds. We have 0x squareds. We have 0 x's. And then we have negative 256 for the no x's. All right. If we set our factor here that we do know, x minus 4 equal to 0, and solve for x, you get positive 4. So the x's that you're missing in your polynomial for x to the fourth minus 256, we have to account for them by putting zeros in their places. Okay, so the first 0 is x to the third, then x squared, then x. And and then the negative 256 is where the no x's go. We drop the first number, which is 1, times 4 is 4, plus 0 is 4, times 4 is 16, plus 0 is 16. 16 times 4 is going to be 64, plus 0 is 64, times 4 is going to be 256, which is 0. So now we can write down our answer. We started with x to the 4th, but we divided that by x, so that's going to be x to the 3rd, plus 4x squared, plus 16x, plus 64. There you go. Okay. Same idea in part B here. We're given a polynomial, but it's x to the 7th. We're missing a lot of terms. So we have 1x to the 7th, 0x to the 6th, 1x to the 5th, 0x to the 4th, minus 10x to the 3rd, 0x squared, 0x's, and 12. So this is going to be a long problem. Well, not a long, but it's a lot of different calculations. X plus 2, set it equal to 0 and solve for x. You're going to get negative 2. And now we can do it. So we drop the first number, which is 1, times negative 2 is negative 2, plus 0 is negative 2, times negative 2 is positive 4, plus 1 is 5, times negative 2 is negative 10, plus 0 is going to be negative 10 again, times negative 2 is going to be positive 20. Add those up, you're going to get 10, excuse me, times negative 2 is negative 20 again. Add them up, you're going to get negative 20, times negative 2 is positive 40. Add them up, you're going to get 40, times negative 2 is negative 80, and negative 80 minus 12, or sorry, plus 12 is negative 68. Okay, now this doesn't work out, but it also says it's not a factor. Okay. So how do we write this? We divided x to the 7th by x, which means we're going to have x to the 6th minus 2x to the 5th plus 5x to the 4th minus 10x to the 3rd plus 10x squared minus 20x plus 40, and our remainder is negative 68 over x plus 2. And that is the answer to that question. Quite long, but still the answer. Okay. So in this one, you're going to use the graph to help us find out one of the factors and then use that to divide our equation that we're given, our function, to figure out the other functions. So if we look at our graph, we're given this point and this point. Well, the first point we found is x equals negative 6. The other point is x equals, I have no idea. So we're going to use negative 6 with our function up here and use it to divide it to find the other function. So we have 3, 11, negative 42. Negative 6 is going to be the term that we're going to divide by. So we drop the first number, which is 3, times negative 6 is negative 18. Add those up, you get negative 7, times negative 6 is positive 42. Oops. Which gives you 0. So the other function that the other factor we're missing is the 3x minus 7. Now we have to put the function that the factor that we do know, which is from the x equals negative 6, but we're going to turn this back into a factor. To do that, we're going to add 6 to the other side, so it's x plus 6 as the other factor. Okay? Excuse me. We're going to do that again for the next one. Okay? For the first point here, we have no idea what this is. All right, for the other point, we know that this is x equals 3. So we're going to use that 3 to divide our 2x squared minus x minus 15. Drop the first number, you get 3. You get 2. Times 3 is 6. 6 minus 1 is going to be 5. Times 3 is 15, which gives you 0. So you know one of the factors is 2x plus 5. And the other factor, if we set if we take the x equals 3 and put it back to be a factor, we have to subtract 3, so it's going to be x minus 3. And these are the two factors that make up the graph and the equation. Okay? So again, we're going to use synthetic division on this problem. It has all of its terms. We're going to just write them down. So we had 2, -4, 1, -6, and 2. Now we're going to find out what f of 5 is. So that 5 is going to be the term you have out in your little box. And do that. I really don't like that line because it's not straight. There we go. Drop the first number, you get 2 times 5 is 10, minus 4 is 6, times 5 is 30, plus 1 is 31. 31 times 5 is 155, minus 6 is 149, times 5 is 745, plus 2 is 747. So in this particular problem, all we care about is the ending number, this number at the very end. So we're going to write f of 5 is equal to 747. That is our answer. All right, same thing in the next question for number 7. We'll write all our terms down. We got negative 1x to the 4th, positive 7x to the 3rd, 2x squared, minus 3x, minus 8. We'll use negative 3 to divide it. So drop the first number, we get negative 1, times negative 3 is 3. Add those up, you get 10, times negative 3 is negative 30. Add those up, you get negative 28. Negative 28 times negative 3 is 84. Plus 3 is, minus 3 is 81. 81 times negative 3 is negative 243. Minus 8 is negative 251. So that is the answer that we're looking for, that back end piece. So g of negative 3 is equal to negative 251. All right. Some problems that are from the last semester. So this is an equivalency. So all you're going to do is combine the like terms and solve it all out and figure out what numbers you get and see if they match up. Okay, so the first one we have, this x minus 2 that's being squared is got to be multiplied by itself. So you multiply it out. X times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is again negative 2x. And negative 2 times negative 2 is positive 4. Okay. We have to combine the like terms in the middle, which gives you x squared minus 4x plus 4. But the other thing we can't do is we can't forget the negative 3x out in front of the whole thing. So we're going to wait to that for last. Now that we have that, we're going to multiply it through our parentheses. Negative 3x times x squared is negative 3x to the 3rd. Negative 3x times negative 4 is positive 12x squared. And negative 3x times 4 is going to be negative 12x. Okay, so that's the answer for the one side. Now we're going to do the other side and see what we come up with. Here we're just multiplying through, so 3x times the two terms in the first parentheses. 3x times negative x squared is negative 3x to the 3rd. 3x times 4 is going to be positive 12x squared. All right, and then here we have negative 2 times 6x, which is going to be negative 12x. So, do these things look the same? They are in fact the same. So you would say yes, because this and this are equal. Okay. Doing the same thing for the next question, number 9. We have to multiply x minus 3 times x plus 5. We get x squared when you do x times x. X times 5 is going to be positive 5x. Negative 3 times x is negative 3x. Negative 3 times 5 is going to be negative 15. Combining those like terms, we're going to get x squared plus 2x minus 15, but we can't forget the plus 2x on the back end. When we do that, we combine the positive 2x's there's two of them, so we have x squared plus 4x minus 15. Okay, so that's our final answer for that part, but we have to do the other side to see what that comes up with. All right, we have to do negative 2x times the two terms in the parentheses, so I'm going to rewrite negative 15 and then plus 3x. But then negative 2x times x is negative 2x squared, and negative 2x times 4 is negative 8x. Now I combine the like terms. Negative 2x squared goes first. The 3x minus 8x is negative 5x, and minus 15. Well, these things don't match, so this is a no. Okay, moving on to quadratic inequalities. First thing we're going to do is we got to set these equal to 0. So we're going to subtract the 15. So we have x squared plus 2x minus 15 is greater than or equal to 0. We're then going to factor this. So we have x and x. The factors of negative 15, or two numbers multiply to be negative 15 but add up to be a positive 2, are going to be positive 5 and negative 3. All right, we're going to solve for both of those. We got x equals negative 5 and x equals positive 3. So if we set each factor equal to 0 and solve for x, that's what we come up with. Now we're going to sketch a graph using these values as our x-intercepts. We have negative 5 here and positive 3 here. Our graph is positive, so it's going to look like something like this. And now we can do the inequality part. So the inequality says it's greater than or equal to. So we want to find things that are above the x-axis. Well, this is above the x-axis, and so is this. So we're going to write our answers for those pieces as interval notations. So it starts on the left from negative infinity, which has to be a parentheses, to negative 5, and since this is a greater than or equal to, it's going to be a bracket. Then we have a break. Start up again at 3 with a bracket because, again, it's got an equal to in it. And it goes towards positive infinity with the parentheses. So this is your answer. For part B, again, we got to set this equal to 0, so we're going to subtract 6 from both sides. So we have 3x squared minus 7x minus 6 is less than 0. If we factor this, let's do the bottoms up method. So we have 3 times negative 6 is going to be negative 18. Two factors of negative 18 that add up to be negative 7, are going to be negative 9 and positive 2. Now we're going to take our first coefficient in front of the x squared, which is a 3, and use that as our denominator. And then reduce. So we get negative 3 over 1 and 2 over 3. Put x's in the bottoms and bring those parts to the top. So we have x minus 3 and 3x plus 2. Those are our factors. If we take those factors, set them equal to 0, and solve for x, we get x is equal to 3 and x is equal to negative 2 over 3. So we sketch our graph, just like the last question. Negative 2 over 3 is, let's say, right there. And positive 3 is, let's say, over here. Again, the graph is positive because the 3x squared is a positive term. So the graph looks like this. Now, this time we're looking for less than. This is the less than sign. So we're looking for things underneath the x-axis. So it's from here to here. So it starts at negative 2/3. And it's a parentheses because it's not less than or equal to, it's just less than. And it goes to 3, and then it stops. And then you're done. All right. Again, number 11 is a piece from last semester. Okay. So end behavior. I'm going to draw a short sketch or a small sketch. So it's we're looking for two things. We're looking for what is the exponent. It's 4, which is an even number. All right, and it's positive, since it's positive 3, which means our graph's going to look something like this. Okay. We want to know what is happening here and here. So as x approaches negative infinity, the f of x, so the graph, is going which direction? It is going up towards positive infinity. All right. Then as you move to the right, as x approaches positive infinity, What is the graph doing? It is going up towards positive infinity. There's your end behavior. All right. For the next graph, we find out that 9 is our biggest exponent, which means it's an odd. And our number in front of the x squared, or x to the 9th, is a negative. So this graph is going to look something like this. Okay. Again, we want to know where this part of the graph is going and where the bottom part is going. So again, as x is approaching negative infinity, so as it moves to the left, what is the graph doing? It is going up. So m of x is approaching positive infinity. As the graph goes to the right, towards positive infinity, what is the graph doing? It's going down towards negative infinity. And there is your end behavior for question part B. Okay. Number 12 is very much like the quadratic inequalities we did just a minute ago. What we're going to do is we're going to take our factors. So we have x equals negative 2, x equals positive 2, and x equals positive 3 by taking the three factors, setting them equal to 0, and solving for x. We're going to graph them all on our coordinate plane here. So we have negative 2, positive 2, and positive 3. Okay. Now, because there are three x's, it is x to the third. And because this 3 out in front is positive, all right, it's going to be a positive graph. Which means our graph starts down here, goes up through 2, down through 2, back up through 3. Okay. We are looking for greater than or equal to. So we're looking for all the parts of the graph that are above the x-axis. So it's here and here. So you have to write the interval notation for those pieces. So it starts at negative 2, and since our inequality sign is greater than or equal to, it's a bracket. Then it goes to positive 2 with another bracket. Then there's a break. Starts up at positive 3, and it goes up as it goes to the right towards positive infinity, which has to be a parentheses. And there's your interval notation for that particular graph. Okay. So, same kind of idea. We have to factor this. We got 2 times negative 6 is negative 12. Factors of negative 12 that give you negative 1 would be negative 4 and positive 3. Use the 2 as our denominator and then reduce. Negative 2 over 1 and 3 over 2 can't be reduced. So we have x minus 2 as one factor and 2x plus 3 as the other factor. We solve them both for x by setting each factor equal to 0 when solving for x. We get 2 and negative 3 over 2. Okay, so on our coordinate plane here, we graph negative 3 over 2 and positive 2. Since our 2 in the original equation is positive, the graph's going to go up. Again, we're looking at the inequality sign. This is a less than, so we want everything that's below the x-axis. So all of this stuff. So we write it out. Since it's just a less than and not a less than or equal to, we have parentheses to negative 3 over 2, comma 2 with parentheses. All right. Next, we're going to do a bunch of factoring. Number 14, there's a bunch of stuff in here, but we can take a greatest common factor out. Each one of the numbers is a factor of 5, so we're going to take a 5 out. And there's enough x's in each term to take 2 x's out, so x squared. Okay. When we do that, we're going to be left with x squared plus 2x minus 8. All right, now we got to figure out, can we factor again the stuff in the parentheses? Okay, and the answer is actually yes. All right, I'm going to keep the 5x squared outside, and I'm going to factor what's in the parentheses. So the two numbers that multiply to be -8 and add up to be +2 are going to be +4 and -2. And that's the full factorization of the problem. Okay. Next, there are 4 terms in here, so we're going to do a factor by grouping without having to find the 2 terms in the middle. So we're going to group these right away, the first 2 and the last 2. Actually, here we go. Okay, out of the first set of parentheses, I can take out an x squared. What's left over is 3x plus 4. On the second set of parentheses, I can take out a 6. And I'll be left with 3x plus 4. I take the parts that are on the outside, the x squared plus 6, and the parts that are left over, 3x plus 4. Now, one thing you have to look for is that piece, the x squared plus 6, is that factorable? Is it a difference of 2 squares, which can happen? If it is, you have to factor it. In this case, x squared plus 6 is not a difference of 2 squares. It's not even a difference. All right. So there's nothing else you can do with it, so you leave it just the way it is. This becomes your answer. Some more factoring. Multiplying 6 times -3, you get -18. The two numbers that multiply to give you -18 but add up to be +17 are going to be 18 and -1. I'm still going to do the bottoms up method. I think it's just faster. 6 goes as the denominators of both the factors. Reduce, you get 3 over 1 and -1 over 6. Get x and x, so you get x plus 3 and 6x minus 1. Part B. In this case, you have a common term you can take out, the greatest common factor. Between 3 and 75, you can take out a 3. You're left with x squared minus 25. Now, x squared minus 25 is a difference of 2 squares. I'm going to keep the 3. I have x plus 5 and x minus 5. So 5 times -5 is +25, but 5 minus 5 is 0, which is why there's no middle term for that problem. Okay, and that is completely factored. Part C, again, we can take out the greatest common factor. There's no number we can take out because x to the 4th doesn't have a number in it that we can take out. Okay, so we can take out an x squared, though, which leaves us with x squared plus 4x minus 12. All right, now the question is, can we factor what's inside the parentheses? I would say yes. I'm going to leave the x squared out in front and then factor the rest. Two numbers that multiply to give you -12 but add up to give you +4 would be +6 and -2. The last factorization, just a simple factor. Two numbers that multiply to give you -18 and add up to give you -7 would be -9 and +2. All right, some of the word problems. So first we have to write an equation that'll make a profit for the arcade each month. So the cost to keep an arcade open each month is $1,000. At the current cost of $5 per person, 100 people go there each month. The owner estimates that for every 20-cent decrease in ticket price, 30 more people will go to the arcade each month. Okay, so that's what we're going to do. We're going to write our profit equation. So P of X will equal, so we're going to do the amount and the value. The amount is how much there is, and the value is how much it's worth. So the amount is the amount of people that are going. So at the current cost, it says 100 people go there. But if you decrease the ticket price by 20 cents, 30 more people will show up. So 30 more people, but we don't know how many times we're decreasing the ticket price, so it's going to be 30x. The value is how much it's worth. currently costs $5 per person, but we're going to decrease the ticket price by 0.2. We just don't know how many times. All right, the other thing we have to account for in our equation is the cost, because we're looking at profit. The cost of the arcade each month is $1,000. So that is your equation. To make an inequality out of that, we're just going to rewrite the equation just the way it was. But we're going to make an inequality out of it. Now, since we've got to make a profit, the left side of the inequality has to be greater than 0. It can't be equal to, because that would be breaking even, and then we wouldn't make a profit. So it's going to be greater than. I'm going to make my greater than sign a little bit prettier. There we go. So there's my inequality. Okay, now we got to determine the price the arcade can charge for tickets to maximize their profit. So what we're going to do is we're going to go over to the Desmos app. I'm going to get out of here and all this other stuff. Sorry about that. I'm going to click on the Desmos app here. I'm going to write our equation. So it was, we have 100 people. We're going to get 30 more if we have a $5 charge, but minus 0.2. And we have a $1,000 cost of keeping the arcade open. So there is our equation. So now we're going to zoom out to find the vertex or the maximum. Let me get a little bit closer to it. Click on the graph, and there's a dot on the top. There's my dot. It says 10.833. Well, I can't do 0.833 for a value, so we're going to round down to be 10. Okay, so we're going to use 10 as our x value. So going back to our problem here. All right, it says determine the price the arcade can charge for tickets to maximize their profits. So the price is what we're looking for. So the price is, oops, sorry. Touched the wrong thing. So the price is right here. So we're going to do 5 minus 0.2 times 10. Oops. So we're going to figure out what that is. So 5 minus 0.2 times 10 gives you 3. So $3 per ticket. Okay. That's it. Next question. A company is hosting a banquet for their employees. The cost of the banquet is $4,400. At the current cost of $90 per ticket, 160 people have bought tickets. The banquet organizer estimates that for every $4 decrease in ticket price, 11 more people will buy a ticket. So again, we're doing the same kind of thing as we did in the last problem. Doing a profit of X. Our amount is going to be that there's 160 people to buy tickets. But if we decrease the price, 11 more people will buy. We just don't know how many times they're going to do that. Okay, then the value is going to be $90 per ticket. But if we decrease that price by $4, we just don't know how many times. That's why we put the X. And the cost is $4,400. Okay, that's our equation. To make it an inequality, we do the same thing we did before. Write down the equation just like it was. But it's going to be greater than 0. Okay, so now we have to, it says use technology to determine the maximum profit the company will make from the sale of tickets, and then what ticket cost will result in the company making the maximum profit. So there's actually 2 questions in that problem. Okay, but we do have to go to our Desmos app and write the equation in. Okay, so let's do that. I'm going to clear out that other equation. There we go. And write the new one. So it was, there's 160 people, but we're going to get 11 more every time we decrease the price. Right now it costs $90 per ticket, but we're going to decrease that price by $4 per ticket. Just don't know how many times yet. And it costs to run the whole thing $4,400. So I'm going to zoom out to go up. See if I can find it. Here we go. Here's my vertex. Let's just get it closer so we can All right, here we go. So we click on the graph, click on the point. So it's 3.977. Again, we're going to round down because we can't go to 4 because that is not the right thing. We're going to round down to 3. So 3 is our x value. Okay, so if we go back down, or sorry, back over to our review, we have 3 as our x term. We want to know what the maximum profit is. We're actually going to have to put in 3 for the x's. Okay, so let's do that in separate pieces, just so you can see it, because one of these is going to have to be an answer that we're going to use. So we put 3 in for the x's. We have 160 plus 11 times 3 gives us 193. That's how many people are going to show up. We do 90 minus 4 times 3 gives us 78. That's how much you're going to charge. Okay, minus 4,400. So we have 193 times 78 minus 4,400 gives us 10,654. This is the maximum profit you're going to make. The other question is, what ticket cost will result in the company making the maximum profit? The ticket cost is right here. So the second part of the problem is $78. Okay, which is why I did them kind of separately. All right, so then the last question is, what is the lowest ticket price that the company can charge and still make a profit of at least $10,000? So what we're going to do is we're going to go back to our equation on Desmos. We're going to write a new equation with the old equation still there of y equals $10,000. Okay, what we're going to do is we're going to find the 10,000 in our graph. There it is. That's the green line. It's a horizontal line because it's y equals. Now the farther part of the graph, so you can see the blue line there. So there's a point where the blue line and the green line intersect. I'm going to click on that point, 7.955. We got to round down, so it's just 7. So what we're going to do is go back to our review sheet. And what's the lowest ticket price the company can charge? So if we do 90 minus 4 times 7 for the ticket prices, 90 minus 4 times 7, the lowest price they can charge and still make a profit of $10,000 is $62. And that is it. All right, please, if you have questions, please make sure you ask and you get your questions answered before you take the test on Friday.